This is experiment number 7, antacid effectiveness by back titration. We'll find the neutralization capacity of some commercial antacid tablets by a method known as back titration, which I'll explain in a second. This will tell us how much chalk is in that tablet, both in terms of the milligrams per tablet and the percent per tablet. So we'll need the mass of the tablet in order to do that. Back titration is a method where you can find the amount of base in this case by reacting it with an excess but known amount of acid. So when you throw in the acid, some of that base reacts, but some doesn't. You find out how much didn't in order to find out how much did. I hope that makes some sort of sense to you. So that'll still be an acidic solution. You titrate it with the base, and then you calculate the amount of base that must have been originally present. Why on earth would we do such a weird procedure? Because the antacid tablet that contains chalk won't dissolve well. Chalk does not dissolve well in water at all. So this is a trick that you can get it to all go into solution and then measure how much chalk would have been there by this back calculation. So here's what we'll do. We'll mass a antacid sample, a tablet. We'll crush it up, put it in a flask, and we'll add this excess HCl, specifically 50 milliliters of 0.1 molar. It's one simple calculation to find out how many moles of HCl are present in that. Since molar means moles per liter, multiply that by liters and you've got moles. So that excess acid that still remains will be titrated with only a pretty weak base, 0.1 molar sodium hydroxide, and later we can back calculate how many millimoles of base we had to start with. So that's why they call it back titration, is because you have to back calculate. So here's what we have. We have an acid, that's our known. We know exactly how many millimoles of acid we have. By the way, a millimole is 1,000th of a mole. That's going to react with the antacid, and we'll titrate it with the base. We know how much base we used. We know how much acid we started with. The rest must be due to the base that's in the antacid. We need 8 calculations. The millimoles of HCl added, I'm not going to read all these, but please calculate all 8 of these things in order. And here's some help for doing the calculations. How much acid was added? Well, if you know how many millimoles of HCl you used per milliliter, and you multiply it by the milliliters, you can get the millimoles. It's similar to what I explained here. How much base was used? Well, we're going to titrate it, and we'll have a given volume of that 0.1 molar sodium hydroxide, right? So if it was 25 mils you needed, that's 0.025 liters times 0.01 moles per liter. That'll give you the moles of sodium hydroxide. You can either do moles per liter or millimoles per milliliter. Either one is fine. How much excess acid was there? Since 1 mole of HCl reacts with 1 mole of sodium hydroxide, the millimoles of sodium hydroxide must equal the millimoles of your excess acid. How much H plus that's acid, was initially reacted with the acid? Well, the acid was neutralized by both the antacid and the sodium hydroxide. So here's the gram total. The millimoles of acid that are total equals the millimoles that reacted with the antacid plus the millimoles that reacted with the sodium hydroxide. So the millimoles that reacted with the acid, there it is right there, equals the millimoles of total minus the millimoles that reacted with the sodium hydroxide. How many millimoles of antacid are there in each tablet? Well, don't forget the calcium carbonate reacts with 2 equivalents of acid to form hydrogen, carbon dioxide, and the calcium salt. Therefore, for each millimole that reacted with the antacid, you got to multiply that, divide that by 2 to get the millimoles of the active ingredient, calcium carbonate. How many milligrams of antacid are in the tablet? Well, if you have the millimoles of calcium carbonate and 100 milligrams is a millimole, you can multiply it through to get the milligrams. Compare that to the mass of the actual tablet, and you should have the percent calcium carbonate. That's just a little bit about the calculations. Today's lab is relatively short. I've got the lab manual in front of me here, and I see that it's actually starting on page 62. It's only 8 steps, so This might not take too long. And these calculations are easy to mess up, so you can stick around and I can give you a little bit of assistance with them if you need it, or you can take off and perform them at home. So I see 8 steps, and it sounds pretty straightforward. One difference today is that we'll be using not a phenolphthalein indicator for the titrations, but one called thymol blue. And when you do that, it does a funny sort of color change to it. The solution will turn pink. I'm reading from the manual, step number 7. Solution turns pink, then faint pink, then peach. At this point, add it dropwise until the yellow end point is reached. So it's the yellow color that you want to use. And if you want to be exact, try to choose a yellow color that has just a hint of green in it. So when we're doing the titrations, some brave group will be going first, and we'll watch what they do. And now when they get to the point where it hits that yellow color with just a hint of green, let's all take a look at it, and we can match up to that color and use that as our titration. It's not as straightforward as a phenolphthalein titration. And so that's what we'll be doing. Don't forget those post-lab questions, and I'll see you guys on Wednesday.